Hello students, in this video let's practice some MCQs from the topic matrices.
If a matrix has 16 elements, then what are the possible orders it may have? So please remember guys, the order when it is of the form m by n, the number of elements is nothing but product of m into n, or in other words, if there is a 2 by 2 matrix, you will know that it will have 4 elements. Similarly, when you have a 3 by 3 matrix, you will know it will have 9 elements. Similarly, when you have a 2 by 3 matrix, you know it has a 6 elements. Same applies even for a 3 by 2 matrix, correct? So, number of elements in any matrix is nothing but number of rows multiplied by number of columns. So, let us see. The first question is saying if a matrix has 16 elements, what are the possible orders it can have? So, you have to check for those options where the product of the numbers is equal to 16. So, 2 into 8, 16, 8 into 1. No, option is eliminated. Option B, 2 into 8, 16, 8 into 2 is 16, 4 into 4, 16, 1 into 16, 16, 16 into 1, 16. Let's go with this answer. Why the other ones are incorrect? If you see in the third option, 4 into 1 is not equal to 16. Similarly, look at fourth option, 2 into 4 is not equal to 16 in the first part. So, that explains why there is a wrong answer. So, now please remember guys, when in the second question is asking what is the transpose of a rectangular matrix. Guys, let us say this is a rectangular matrix with the order 3 by 2. You know when matrix with an order 3 by 2 indicates there are 3 rows and 2 columns, and when you apply transpose to this matrix, you know it will have 2 rows and 3 columns. So, a 3 by 2 matrix when transposed becomes a 2 by 3 matrix, which is also a rectangular matrix. So, essentially transpose of a rectangular matrix will result in a rectangular matrix itself, which is option A. So, second one is A. Now, coming to third one, transpose of a row matrix. So, what is a row matrix? There is only one row and n columns. So, when you transpose a matrix with the order 1 by n, it will become n by 1. Essentially, since originally it had only one row, now it will have only one column. So, transpose of a row matrix will result in a column matrix, and transpose of a column matrix will result in a row matrix. So, what is the answer for your third question? Third question, the answer will be C. Fourth question, two matrices A and B are multiplied to get AB if. So, the question is, when is the product of matrices possible is the question, okay. So, we already discussed that whenever you are multiplying two matrices A and B, the product is possible only when the number of columns of matrix A is equal to number of rows of column B, which is clearly mentioned in option C. So, fourth one we will go with option C. If mod A is equal to 0, that means the determinant of the matrix A is equal to 0, then we call the matrix as a singular matrix. Now, we discussed many times that when you have to find out the value of A inverse, when you have to find out the Cramer's rule multiplication, these work only when we have a non-singular matrices. For a singular matrices, this determinant is 0, and when we put the determinant 0 in the denominator, it will become anything by 0, it will become indeterminate form, right. So, now coming to your sixth question, if A is a symmetric matrix, then A transpose will be what? So, if A is a symmetric matrix guys, A transpose will become A. That is what we discussed. Now, the question is seventh one, if the order of a matrix is M into P. So, A is a matrix with order M into P, and B is a matrix with order P into N, and when you multiply A into B, that is possible only when the columns of the first matrix is equal to rows of second matrix, then we will get a matrix, let us say C, which is the product of A and B. The order of the resulting matrix is given by these two, so the order will be equal to M by N, which is given in option A. So, seventh one we will go with option A, okay. Eighth one, if A and B are two matrices, then which of the following is true? A plus B is not equal to B plus A transpose whole transpose is not equal to AB is not equal to B. Yes, option C beautifully works, because matrix addition is commutative and A transpose whole transpose is equal to A. Both A and B are incorrect. Option C is the correct answer, okay. Now, coming to the question ninth one, what is the value of A if A is a singular matrix? What is the A? The matrix A is given as 2, 3, 4 A. You know any matrix is singular matrix if mod A is equal to 0. Mod A is nothing but determinant. So, determinant is what? 2 into A minus 3 into 4, 12. So, 2A is equal to 0. So, A is equal to 6. So, the value of A is equal to 6 is given in option B. So, ninth answer is option B guys, okay. Now, coming to your 10th question, if the matrix A is given by 2I, 3I, 2I minus I and it's also given I square is equal to minus 1, he is asking you to find what is the value of mod A, right? What is mod A? 2i into minus I minus 3i into 2i, any order, 2i into 3i or 3i into 2i. So, minus 2i square minus 6i square minus 8i square minus 8 into minus 1. So, the answer is 8, which matches with option B, guys. Okay. So, 10th answer is option B, right. Now, 11th question, let me write down A11, A12, A21, A22, A31, A32 into a matrix A will result in B11, B12, B13, B21, B22, B23, B31, B32, B3. The reason why I am writing is only for explanation, but in the exam there is no need to write such a large process. So, this is a matrix of 3 rows and 2 columns, and when you are multiplying you are getting a matrix with 3 rows and 3 columns. So, 3 rows and 2 columns order matrix sum B, you are multiplying with a matrix A with order I do not know, and you are getting a matrix of order C with 3 by 3. That means you know that this is possible only when the columns of the first row is equal to the rows of the second matrix, columns of the first matrix is equal to rows of the second matrix too, and this and whatever is here will give you the order. So, this 3 represent this 3, so this 3 represents this 3. So, when you are multiplying a 3 by 2 matrix with a 2 by 3 matrix, since it has 2 rows, 2 columns and 2 rows, they basically ensure that matrix multiplication is possible. The resultant outcome is a 3 by 3 matrix. So, A is a 2 by 3 matrix. So, my answer for 11th one is option B, right. So, what is the order of matrix A? Order of matrix A should be 2 by 3, okay, right. Next, so A 2 minus 3 4 5, B 1 5 6 and minus 7, okay, and C is 2 5 3 4, okay. So, let me show you 15th question, product of A into B, okay. So, let me write in a big way, this with this. So, 2 into 1 plus minus 3 into 6, next 2 into 5 plus minus 3 into minus 7, 4 into 1 plus 5 into 6, 4 into 5 plus 5 into minus 7, correct. So, 2 into 1 2 minus 18 minus 16, 10 plus 21 31, 4 plus 30 34, 20 minus 35 minus 15. So, minus 16 31, 34 minus 15, minus 16 31, 34 minus 15, option A. So, BA also you do it, you will get in a different case. 17th one. So, the product is, though it is written as plus, so let us do the multiplication. A minus B, B minus A, you are multiplying this with A B and minus B A, right. Otherwise, if you are just adding, right, A plus A should become 2A, none of the options 2A is there. I think is referring to multiplication. So, plus make that correction. So, this with this. So, A into A plus minus B into minus B, this with this, A into B plus minus B into A, next B into A plus A into minus B, B into B plus A into A. This is my final matrix, A square plus B square, AB minus BA, BA minus AB, B square plus A square. So, these are zeros, here A square plus B square, 0 0, A square plus B square. So, my answer will be option A, guys, for 17th one, largely because it is a multiplication. You can do similar logic even for 18th one, little tougher calculation. So, 19th one, I guess he is now referring to addition. So, 19th one there is a plus, so clear symbol. So, 19th L minus P, which is there in option D, M plus Q, N plus R, 0 plus S is nothing but S, it is not O, it is 0. So, we will go with 19th one as option D. 21st question is also multiplication, 1 2 5, when you are multiplying with 3 4 5 6, guys, okay. Please remember, this is a 3 by 1 matrix, this is 1 by 4 matrix. So the matrix that you get should be a 3 by 4 matrix. Okay, so that means the first row with this essentially 3, first row with the second column 4, first row with the third column, first row with the fourth column, second row with the first column multiplied, second row with second column, second row with the third column, second row with the fourth column, third row with the first column, third row with the second column, third row with the fourth column, third row with the fourth column. So the outcome that you got is also a 3 by 4 matrix. Now go to 22nd question. If you are multiplying a matrix x, y, 2, 3 into 1, 2, 3, x, y, z, what are you going to get? X, y, if you multiply with 1x, you will get x plus y, x, right? X, y with 2y, you will get 2x plus y square. X, y with 3z, 3x plus yz. 2, 3 with x, y, 2 plus 3x. 2, 3 with 2y, 4 plus 3y. 2, 3 with 3, 9, 6 plus 3z. So that will be your answer. X plus yz. So 22nd one, the answer will be option B, which is matching with my answer. Okay. 25th one, he's asking if A is a 2 by 3 matrix and B is basically a 3 by 4 matrix. He's asking to find out the value of AB. Is asking, does AB exist or BA exists? According to me, for 25th question, AB exists because the order of A is 2 by 3. The order of B is basically 3 by 4. So AB exists, whereas if B and A, if I write in this order, correct, since these two are not equal, BA does not exist, AB exists. So I will go with option A. AB exists but BA does not exist. Okay. If A value is given as 6539, what is asking as A transpose whole transpose? You know the formula, A transpose whole transpose always equal to A. So you don't have to do it. So 32nd question, the answer will be A. So 34th one, the matrix that is represented here is 0, 3, minus 4, minus 3, 0, minus 5, 4, 4, 8. So he is asking what kind of matrix is this. Okay, first we need to check whether it is a symmetric matrix. What is a symmetric matrix? A transpose is equal to A. So just find out A transpose. 0, minus 3, 4, 3, 0, 4, minus 4, minus 5, 8. Is it the same matrix? No, it's not a symmetric matrix. Second, is it a null matrix? No. Null matrix means every element of matrix should be 0. Is it skew symmetric matrix? A transpose should be minus A, 0, 0, minus 3 plus 3, 4 minus 4, minus 3 plus 3, 0, 0, minus 5 and 4, it fails. So it's not skew symmetric also. What is the answer? None of these. Okay. So coming to your last question, if the value of the matrix A is given as 6, 10, 3, 5, what kind of matrix is this? Okay. So let's find out delta A. 6 into 5 minus 3 into 10. So 30 minus 30, which is equal to 0. That means it's a singular matrix. So what is the option? 35th answer is A. So please remember, whenever I use the term I means it's an identity matrix. Identity matrix or a unit matrix where the diagonal elements are 0 if it's a 2 by 2, or if it's a 3 by 2 matrix 1 0 0 0 1 0 0 0 1, that will be it. So we have used the same notation in your question number 33, where I represents a unit matrix with 1 0 and 0 1 as the elements. Okay, so that ends your matrices. Next time we look at another chapter.
It's time to target top commerce colleges. Explore comprehensive CUET combo pack from OneFin by Indigo Learn.